happening right now.
Okay, very good.
There's I think instruction for 5 people, so let's see, but
So maybe
maybe
I
wait
can
for five.
few minutes, 5 minutes is.
Yeah. This one, yeah, let me know if you need it.
Okay, thank you.
Not in depth, not in depth. I mean, the breadth, of course, you'll need. No, I don't need all of these, but it's good information. And I do this more at work now. So it's like, you might as well learn it, you know? You're doing structures, right? Yeah. Have you been able to, like you say, get through the books or finish things? Or
Not
still studying?
completely.
Okay.
I'm still struggling because
I think that's part of the
I
challenge.
didn't have a timber in
Sure. Okay.
bachelor, not in my master.
Mm-hmm.
I have no idea about the timber or masonry,
Yeah, masonry was good.
but they are not difficult
No.
subjects. But
Yeah,
I usually
timber has a few more unique characteristics to it just because of the material, obviously, but if you understand how to design, your structural analysis doesn't change. There's just a few tweaks associated with timber, going from, say, steel or concrete. If you get that, I'm pretty sure. Right.
the professor, the instructor for the steel was my professor in calculus.
Okay. Oh, no way. Okay. Yeah. Yeah.
I'm familiar with his method.
Right, his style.
Yeah.
See, that's funny. I went to Calpoli too, but I didn't get a chance to take Drake, and I was so disappointed because it wasn't as great. And I'm hearing all these rave reviews about Drake. I'm like, oh wow. So when I see he's finally teaching the course, I'm like excited to be here. Sitting in front. Yes, I can finally say I had Drake. You're still.
He's very
He's good.
organized,
Right, very thorough.
up to date.
And he adds a level of excitement to the course that makes it easier to learn. There's something to be said about that. It's one thing to kind of like this is maybe isn't the most exciting material, and if you approach it like that, then it's tough for your students to get say excited about it too. So when you add a level of enthusiasm and you show that you care about the material and what you know, it's easy for people to buy into that. Passion goes a long way. So it's one thing to be organized, but it's another to actually care about what you're doing. So yeah, this has been a fun ride so far.
We wait a few more minutes. I think we're expecting a few more people. Okay, okay.
Yeah,
Okay.
I don't see anyone else.
Okay, very good. Thank you. Okay, good morning. My name is Iraj Nasseri. Do you hear me? Okay. I am Chief Hydrologist of County of Los Angeles and also faculty at University of Southern California, teaching classes in hydrology, hydraulics, groundwater management. So I've been teaching this class for maybe last 15 years. So basically try to help you that basically if asking you a few questions in hydrology, your PE, you'll be able to answer it. Some of you may have some backgrounds in undergraduate or in practice in hydrology, groundwater, and some may not have. So basically I try to introduce some concept, very simple approach, and definitely you have to study on your own as well. Just 6 hours was not enough for a class. Usually they're offering it in one semester. So I highly recommend that those areas that I will cover, I believe that based on my experience and talking to people who took these classes for the last 10 years, now currently is a multiple choice. Try to at least apply some of those concepts that you should expect in the exams. So we'll try to help you. The topics that we cover in this class consist of mainly of three major areas in hydrology. One is called the surface water hydrology. Second one is, which basically surface hydrology, I'm going to introduce a couple of methodology that use in exams and also use in practice, which is the rational method and unit hydrograph techniques. These two methods are widely used in practice in most agencies, and also generally you should expect 1 or 2 questions on this field in these topics. And the topic is to do with developing a kind of relationship between the rainfall or runoff. Really, as a hydrologist or a hydraulic engineer or civil engineer, before you design a drainage system, flood control system, you have to come up with the flow rates. And not only the peak flow rates to size your storm drain system, and sometimes the volume, because sometimes you need detention, how much water is available to recharge or retain or detain, whatever. So the hydrograph. So developing a relationship, these two techniques develop a relationship between rainfall and runoff. And why it is important? Because generally measuring rainfall is easy. It's simple. You have a device, rain gauge. You can install it anywhere. And now everything's real-time, automatic. In the old days, you have to go and measuring from hours to hours or whatever. But now with this technology, you have real-time data available. And generally, we publish it. During the rains, you can go to our website, and any minute you can determine how much rain is falling in any location in the county of Los Angeles. But measuring the runoff is extremely difficult, it's time-consuming, assuming you have a channels, and you have to go and measure the velocity, and if the cross-section on the invert, the bottom, the middle is completely time-consuming and very difficult. Of course, we have many stream gauges. It's good to have those data available through the stream gauge for calibrations of the models. But generally, with measuring the rainfall, and with these two techniques, I'm going to talk about it, which is the rational method and the unit hydrograph technique, you can relate your rainfall to runoff. So once you have rainfall data, which is easy to acquire those data, using these two methodology, you can convert your rainfall into runoff. So in any location, you have a catch basin, you have a storm drain system, flood control channels, you can determine how much peak flows and how much volumes using these two methodologies. The second topics we're going to talk about is about reservoirs. So once in a while, I have seen that they expect you that you'll be able to determine based on the demand, supply times, your inflow from natural flows coming to reservoirs, water supply, irrigation, hydroelectric types, and how much is the demand based on how much naturally flow generated to the rainfalls, to the snow melting, and how much you demand for irrigation water supply. And they ask you that what storage you require. Or basically, you size the reservoirs needed to supply your supply your demand, or sometimes you are limited physically by the storage, and they say, okay, this is the maximum storage available. You have your inflow. The question is this kind of a question they might ask you that, okay, based on that, what's the maximum supply or maximum demand that you can guarantee? So there are two types of questions. We're going to talk a little bit about those reservoir analysis, supply-demand types analysis. And third topic is about groundwater hydraulics. As you know, groundwater is a major source of water supply. We in Southern California, 1/3 of water supply needs is coming from groundwater. In the last several years of drought, we heavily depended on the groundwater, unfortunately, to the excessive pumping and withdrawing. A lot of these water tables has dropped significantly and caused subsidence and contamination and so many other things resulted. We are extremely, in LA County, involved. We're capturing our stormwater. We have 15 dams. During the storm, we capture all those in the reservoirs and we put into the ground through the groundwater recharge. We're quite extensively involved with that type of practices for groundwater. So we're going to talk about some wells, hydraulics of wells. If you need to determine, basically an aquifers or groundwater basin, how much water you can pump, and how hydraulically a pump wells can basically functioning. We're going to touch those areas for groundwater. Depends on what type of aquifers, confined aquifers, and confined aquifers, and so forth. Yes.
Out of these three topics, is there can you tell us which one would be on the depth versus breadth?
I really don't know how. Definitely groundwater reservoirs type things. Definitely is on the depths because they are more advanced and less common in civil engineering practice. Really is more a specialized field. But I think the first part, the surface water, rainfall runoff relation, this is something that you have to have master of it, Sometimes we may not even have a question on groundwater or reservoirs, but sometimes once in a while you might see it. So surface water hydrology is the major topics that maybe you expect it on that. I think a question for those on the, I have to repeat that question. Question was, which of these topics I discussed really you should expect in the depths part of the analysis, and I will say maybe only groundwater and the reservoirs maybe in the depths part of the exams. No, I mean, so those that taking the water resources as the major field of there, because in PE you have structures, waters, environmentals, traffics, and basically based on that selection, the questions you expect, is in which should be the depths of the knowledge that you should have it.